Okay, welcome back to part 2 of our data transfer instructions videos. And this one is meant to dive into an example using load and store word instructions. Okay, we introduced them in the prior video, and I think we need to have some explanation of seeing them in action to get familiar with how to use them properly. Start things off, I'd like to take a look at this short little C program here. Kind of a stupid program, but it's meant to kind of illustrate a couple key things, right? So we're going to use an array here to signify memory. Okay, so we're going to use that to represent our memory. Okay, and this first part here is effectively just initializing an array. Okay, so just initializing an array. There's really not too much going on there. Okay, effectively we need to write to this memory area. So we're going to take this information and we're going to effectively store it in memory. The key word there being store. Okay, down here we're just going to add 10 to each memory location. Okay, add 10 to each memory location. We're going to need to read memory, which is a load, right? We need to load it into a register to read it. And then when we have the result, we're going to take that result and we're going to store it back in a memory. All right, so we'll get to that. We'll look at that. Okay, let's take this first part here. Let's go over that first, and I'm going to show this all in ARM assembly, obviously, so that we can really make sense of this. Okay. So we have an array, and we need to define a base address. Okay, we need to define a base address for the array. And we will see later on about how we can have a more meaningful base address, right? Something that's a little bit more explicitly defined, that has some. Well, we're going to look at stack memory. That was something that you've seen prior in another course, and we're going to look at that in the context of really managing the memory addresses. But we're gonna wait on that. We're not going to do that right away, just to keep things simple. And I just set, in this example, I just set the base address to 1024. Okay, I just made that number up, right? We'll look at using something called a stack pointer later to be able to have a more meaningful location for where to store things, but we'll save that for another day. Okay, so that's the base address, and so I'm just storing that here in register 2. Okay, it's the base address. Okay, we have our loop. Here is our loop, right? Just kind of flipping back over here. It's a loop that runs to the size of the array, right? 0 to less than 10, so 0 through 9, right? So here's our loop. We have 10 in register 1, right? R0 is representing our I. Okay, we've seen how to create these for loops before. What I really want to drill down into is the body of the loop here, okay? Because we've already talked about creating these for loops prior, so they're not that interesting. But what's really interesting is here, this part, okay? What we're doing, right? Remember, R0 is our I, right? Here, R3, we've got these two pieces of information. Okay, when we look at the store instruction, we have this is the base. And we're going to add it plus our offset. Okay, where our offset is 0. Initially, R3, notice gets initialized to the value of R2. So this base address here, R3, is going to equal this up here. Okay, Now that makes sense, right? Because the first thing we want to store is we want to take R0 and store it in the address of R3 plus 0. So the address of R3, right? R0, that's our I, is going to be 0, right? I starts at 0. It's going to go 0, 1, 2, 3, 4, right? Keep going up. So effectively, we're going to have something like this up in our... As we loop through it, we know we're going to have this type of situation. Right? We're storing 0, 1, 2, 3, 4, 5, etc., right, in our memory address, right? Look at the next line here after the store. R3 equals R3 plus 4. What we're doing, right, is remember this address here for the next thing in the array is really 1028. It's 4 over because it's 4 bytes over. Okay, we're adding 4, right? We're adding 4. We're moving over 4 bytes. Okay, every time we loop. So R3 is keeping track of the address where we want to write the next thing in the array. Okay, so that's what's going on in this first example, right? Is it's going to keep moving R3 over by 4, right? So then write the next thing. It's keeping track of the address. Okay, that makes sense, right? Because we can't really use I here. Effectively, this, if I is the index, we need to remember that we need the index multiplied by 4, because if all our numbers are 4 bytes, we're going to assume all our numbers are 4 bytes, right? And we need that added by the base address, right? The original base address of the array, right? Original base address 1024, right? R3 just keeps moving over by 4 bytes, okay? Right, we can't use each address. If we use each address, we're only storing 1 character. Or 1 byte. The character is also a byte. Right. All right. So watch that again if you need additional clarification on that part. Right. I'd like to focus on this next part here. Right. We have this array. We need to read the memory location that we just initialized. We're going to add 10 to it. Right, and then we're going to write it back to its same location. Okay, so we have a similar loop, right? The loop's going to run the same number of iterations. Okay, the body looks different. Okay, by the way, we're resetting R3. Okay, we're resetting it back to the original location. Right? I don't know if that purple might be hard to see, but we're resetting it back to the original location. Okay? And then what we're doing is down here, right? We're reading at that location that we just showed, right? Location 1024. We're reading from here. Okay? And we're putting that result into register R4. So R4 is going to get the value, it's going to start at value 0, right? It read that memory location, okay? And then we're adding 10 to it. R4 equals R4 plus 10. So we're going to add 10 to that, okay? Because remember, we cannot add anything directly into memory. We have to bring it from memory into a register. Then we can operate on it, right? We can manipulate the information. We can use it, read from it, do whatever we need to do. And then we have to write it back, right? It's because the registers are fast enough for us to operate and have those calculations on. So we took that 0, we loaded it into a register. We then added 10 to the register. Now we need to store it back. We go R4, store that back in that memory address. So we're going to come back up here, right? And we're going to go ahead and we're going to store that information, right? R3 equals R3 plus 4. We're going to go to this next address, 1028, right? We do the same thing when we come back around in the loop, right? We load that location, 1028. We're going to load it in R4, value 11, okay? R4 equals R4, it's value 1. Excuse me, R4 equals R4 plus 10, so we make it 11. Take that R4, store it back in the address up here, 1028. So it becomes value 11, right? R3 equals R3 plus 4. Go to the slide one further over to the next address, 4 bytes over, 1032. Okay, and so on. All right. So the key thing is we need to keep track of addresses, right? We need to keeping track of where things are going, all right? So some of the biggest lessons of this is just understanding, like getting some practice of how the addresses are stored, right? Keep remembering that they're every 4 bytes, right? If we have a 4-byte number, we need to move over by 4 bytes to store the next one, right? And if we're manipulating data, remember, it has to go into a register. We then manipulate it, right? And then we can store it back, okay? There's ways of doing a little bit of math. So far we've been doing sequential access. We're walking the array one location at a time, okay? But if you needed to do random access, right? If you needed to access a specific location in the array, right? So say I wanted to go to address for some index, right? Whatever that is, right? Remember, it's the base address, okay, plus the index times 4. Okay, to do random access, you just need to compute this to randomly go to any location in the array, right? You just need to compute that, assuming that everything we're storing is 4 bytes. Okay, if you're storing something that was 1 byte, you have a different multiplier here. Okay, for multiplying by 4, remember that's a shift left. Okay, that's a shift left by 2. All right, it's very easy to compute that multiplication. Just shift left by 2. All right, and in assembly, that's our logical shift left operation. Okay. All right, so we'll get more practice later on, but this should give you some good foundation in using these data transfer instructions, getting familiar with what they do, what they look like, and we'll get some practice using them. All right, so thanks for watching, and take care.